Have you ever wished your AI assistant could actually remember your conversations from last week or even last month? Well, today that's exactly what we're going to build. Forget the goldfish memory. We're giving our AI an upgrade with long-term memory, turning it from a simple chatbot into a truly intelligent agent. Stick around, because by the end of this video, you'll know how to build an AI that learns, adapts, and remembers just like a human. So, how do we give an AI a memory? It's not as sci-fi as it sounds. We're going to use a powerful three-part system. First, we need a place for the AI to store its memories, which we'll call the knowledge vault. Second, we need a way for the AI to recall the right memories at the right time. We'll call this recall logic. And third, we need a mechanism for the AI to continuously learn and update its memories on its own. This is the learning loop. Let's dive into the first component, the knowledge vault. Imagine a massive, super-organized digital library. That's our knowledge vault. This isn't just a simple text file. It's a specialized database called a vector database. Why vectors? Because vector databases don't just store text, they store the meaning and context of the text. When we have a new piece of information, say a user preference like "I love sci-fi movies," we don't just save the sentence. We use an embedding model, which is like a universal translator for AI, to convert this sentence into a numerical representation, a vector. This vector captures the essence of the statement. Every new piece of information, every conversation snippet, every document we feed the AI gets converted into one of these vectors and stored in our vault. So, our knowledge vault becomes a rich, multi-dimensional map of information. Think of it like a galaxy where similar concepts are clustered together like stars in a constellation. This structure is what allows for incredibly fast and context-aware retrieval, which brings us to our next key component. Now that we have our memories stored, how does the AI pull out the right one? This is where recall logic comes in, and the core technology here is called Retrieval Augmented Generation, or RAG. It's a game changer. Here's how it works. When you ask the AI a question like, "What kind of movies should I watch tonight?" the AI doesn't just guess. First, it takes your question and converts it into a vector, just like it did with the memories. Then it goes to the knowledge vault and searches for the vectors that are closest or most similar to your question's vector. In our example, it would find the vector for "I love sci-fi movies" because it is semantically related to your query about movie recommendations. This is the retrieval part. The AI pulls out this relevant memory. Then comes the augmented generation part. The AI takes the original question and the retrieved memory, the context, and feeds both into a large language model like GPT. The prompt essentially becomes, based on the fact that this user loves sci-fi movies, what kind of movies should they watch tonight? The LLM then generates a much more personalized and intelligent response like, since you're a fan of sci-fi, you might enjoy Blade Runner 2049 or Dune. See the magic? It's not just recalling a fact, it's using that fact to reason and generate a better answer. This RAG process is the heart of making our AI feel like it truly knows you. It can pull up past conversations, remember details about a project you're working on, or recall specific instructions you gave it weeks ago. It's the difference between an assistant that asks, "Who are you?" every time, and one that says, "Welcome back. Ready to continue our discussion on quantum physics?" This system makes interactions smoother, more efficient, and infinitely more useful. But we can take this one step further. What if the AI could learn and update its own memory without our help? This is where our final piece of the puzzle comes in, the learning loop. A truly autonomous agent shouldn't just rely on the information we initially give it. It should be able to learn from its own experiences and interactions. The learning loop is an automated process that allows the AI to curate its own knowledge vault. Here's a simple way to think about it. After every interaction, the AI can ask itself a critical question. Was there any new, important information in that conversation that I should remember for the future? Let's say you tell the AI, "My company's new project code is Project Phoenix." This is a new, valuable piece of information. The learning loop is a system we designed to identify such novel facts. It could use another AI model to analyze the conversation transcript and extract key entities or summaries. For instance, it might generate a summary like, User's new project is codenamed Project Phoenix. This summary is then automatically converted into a vector and added to the knowledge vault. The next time you ask, "What's the code for our new project?" the RAG system will instantly retrieve this newly learned fact and give you the correct answer. This loop of interacting, identifying new knowledge, and updating the memory vault is what makes the agent truly adaptive. It's no longer a static tool. It's a dynamic entity that grows smarter with every conversation. It can learn your new preferences, keep track of evolving project details, and build a long-term understanding of its world and its users. So let's recap the entire architecture. We have our user interacting with the AI agent. The agent takes the user's input and uses retrieval augmented generation. First, it queries the knowledge vault, which is our vector database, to find relevant past information. This retrieved context is then combined with the user's original query and sent to a large language model. The LLM generates a context-aware, intelligent response. But it doesn't stop there. The entire interaction is then fed into our learning loop. This loop analyzes the conversation, extracts new important information, and automatically updates the knowledge vault. This creates a virtuous cycle of continuous improvement. The more you interact with the agent, the smarter it gets. Putting this all together, you get an AI that's not just a conversationalist, but a partner. An agent that can help you manage complex projects by remembering every detail. A creative assistant that recalls your unique style and preferences. A personal tutor that remembers your learning progress and tailors lessons just for you. The possibilities are truly endless. This three-part system, knowledge vault, recall logic, and learning loop, is the fundamental blueprint for the next generation of artificial intelligence. Building this might sound complex, but the tools are more accessible than ever. There are amazing open-source libraries like LangChain and Llama Index that simplify this whole process. And cloud providers offer managed vector databases that are easy to set up. You don't need to be a top AI researcher to start building. With a bit of Python code and an understanding of these concepts, you can create your very own AI with a long-term memory. I hope this overview has demystified how to build more intelligent, memory-enabled AI agents. We've gone from a blank slate to a fully fledged architecture that can learn and adapt over time. This is the future of human-AI collaboration. If you found this breakdown helpful, imagine what else we can build together. Thank you so much for watching. If this sparked your curiosity, make sure to hit that like button and subscribe for more deep dives into the world of AI. Let me know in the comments what kind of intelligent agent you would build with this technology. I'd love to hear your ideas. Until next time, keep building, keep learning, and I'll see you in the next video.